So we need to find the area of the largest rectangle that can be inscribed in a specific ellipse. So let's figure out what this ellipse is. Let's sketch it. And you'll be able to guess roughly what this thing looks like, and then we'll have to actually solve to be more specific. Okay, so first of all, let's draw ourselves some axes. And so first plot, and if x equals 0, that implies what? Y is equal to plus and minus 3, because we have this nice format for the ellipse that lets us see this easily. If y is equal to 0, x is equal to plus and minus 4. Everything is a nice square number to make this easy for us. If x is 0, y is plus and minus 3. And if y is 0, x is plus and minus 4, so it's elongated like this. Is that even? I can't tell. And let's say we want to draw an ellipse. I can't draw an ellipse, but I can draw a circle. And trying to draw a circle and then stretch it to fit more. Hey, that's pretty good. Okay, so now I'm going to just move these guys over here. There we go. We have an ellipse. Okay, now what is the area of the largest rectangle? So there's going to be a rectangle that probably looks like that. Okay, so we want to figure out what the area is. Well, I need to know what x and y are, and I'm going to just consider this area, because can you see that if I maximize 1/4 of the area, I'm maximizing the whole area. So I'm only going to worry about the positive cases. So I'm going to say my second step, solve for quadrant 1 only y equals. Okay, so y squared over 9 equals 1 minus x squared over 16. Y squared is 9 minus 9x squared over 16. Well, I'm going to take the 3 out anyway. Okay, great. Now, what's the area? Area is just x times y. Again, it's 4 times x times y. And that's what I did in the answer key. But I'm going to do it this way. And when I'm done, I will, well, it does say find the area. Yeah, just for consistency, I'm going to put a 4 here. But you're going to maximize the same function. It's not going to matter. Okay. So area is 4 times x times 3 times this mess. Now, there's something that I can do, but I don't know if this is going to confuse anybody. But I will just say this. If I wish, I can square the area and get rid of the square root, but I will introduce an x squared here, and the 12 will turn into 144. I can maximize the square of the area. By maximizing the square of the area, I would be maximizing the area as a side effect. Still find x, plug it back in, but I plug it back into area. So that's a trick you can use if you want to cut down on some of the nonsense. But I'm not going to do it only because some people are going to be unhappy if I do that. Okay. Another trick you could use is you could put the x inside here by turning it into x squared. So then this would be x squared and this would be x to the 4th. That's another thing you can do. So there's a lot of different ways you could branch off at this point. You don't have to leave A exactly the way it sits there on the page. Okay, but let's pretend we take the option, or let's do this. Let's take the option to just leave A exactly the way it is, which is what most students will do. And this next step is we're going to take the derivative. I'm going to move over to here. Okay, a prime is first times the derivative of the second situation. And it's going to be one of these chain rules inside the product rules. So the first times the derivative of the second and then times the derivative of the fly and plus the derivative of the first times the second. Okay, see, it's looking kind of messy. That wasn't necessarily the best strategy, but anyway, let's continue and see what happens. We want to set this equal to 0 and solve for x. So one thing is we can definitely get rid of the 12s because it doesn't matter for the equals 0 case. And what else can we do? I'm going to multiply by this square root business because I don't like it. This mess, I'm going to multiply by it. And what's going to happen is, in this case, it's going to get rid of this piece. And in this case, it's going to raise the exponent. Okay, so this will help the algebra somewhat. So, let's see. I'm also going to get rid of these 12s while I'm at it. Okay, so a prime equals 0 if x times 1/2 times, so that piece disappears entirely, and then we have minus 2x over 16 plus 1 minus x squared over 16. That has to equal to 0. That's good. See, I'm happy because now I've actually gotten rid of the square root. It's gone, which I didn't want it hanging around anywhere. Anyway, okay, so what am I going to do with this? Okay, the 2's cancel out. I know you wanted to cancel the 2 and the 16, but whatever. I'm going to have minus x squared over 16 plus 1 minus x squared over 16 equals 0. 1/16 and 1/16 is 1/8. Is x squared. So step 5. There's really no step 5. I'm just continuing and I want to know where my work moves to. So x is equal to the square root of 8. Why did I write a 3? I have no idea. X is square root of 8. Now we need to figure out what y is. Well, we can go back to our original equation. Okay, or you know what, I'm not. I'm going to just go back to here. That's the easiest place to grab y from. X squared? See, x is the square root of 8, and so when you square it, you just get 8. Oh, sorry, 8 over 16. So that's a half. 1 minus a half is a half. Y is equal to 3 over square root of 2. Okay, so this guy is going to equal to square root of 8, 3 square root of 2. Alright, now it says find the largest area of the largest rectangle. So we haven't actually finished. So we have to finally finish up. Area is equal to 4xy, 4xy. And you may say, well, I can't clean this up, but I can. You know why? Because this is equal to 12 times square root of 8 over 2. Because those two square roots can be combined. Then you get square root of 4, and that's 2. So the answer is 24. Okay, that is area max. Now we go back and read the problem and make sure we answered all the parts of the question. Find the area of the largest rectangle That can be inscribed. Yes, we found the area of the largest rectangle. We did.